Hello all, welcome to CST206 operating system video lecture. In this lecture, we are discussing about deadlock detection and deadlock recovery concept. Before we discussing about this topic, we have to discuss what is meant by deadlock. Deadlock means it is the condition at which when a process requests resources and if the resources are not available at that time, the process enters a waiting state. Deadlock is also caused by due to the previous processes, and due to this the current process may be turned as a deadlock condition. There are several algorithms are used to deadlock prevention and deadlock avoidance. If some these algorithms haven't able to prevent or avoid the deadlock, then we are using an algorithm for examining the current situation, that is running the algorithm at regular intervals. If we found the deadlock, then we have to use an algorithm to recover the deadlock. There are several ways to detect deadlock and recover the deadlock. About methods to detect deadlock. Based on the condition, the methods are single instance of each resource type and several instances of each resource type. Single instance detect the deadlock by using wait for graph, and in the case of multiple instance, we are using Banger's algorithm. If the resources have only a single instance, we are using a wait for graph which is derived from resource allocation graph. When the resources are removed and the connections are connected properly, we will get a wait for graph. If we get a cycle in the subgraph of wait for graph, then the deadlock is found. To obtain the deadlock, the algorithm runs periodically. In the case of several instances, the wait for graph is not applicable. Instead of that, we are using safety algorithm, which is a part of Banger's algorithm. To implement the safety algorithm, several data structures are used. First one is available. It is indicating the available resource of each type. And the second one is allocation. It defines the number of resources of each type currently allocated to each process. And the third one is request. It is a n by m matrix indicating the current status of each process. And the next one is need. It indicating the remaining resources of each process. To find the need, we are using a formula. Need equals to request minus allocation. And the last one is finish. It is a vector of order m showing boolean for the process have been finished or not its task. Let's consider work and finish be the vector m and s respectively. Initialize work equals available and finish of I equals false for I equal to 0 to n minus 1. The second step is find an index such that both the condition have been satisfied. First condition is finish of I equals false, and second condition is request of I is less than or equal to work. If no such I exists, then go to step 4. The third step is following the steps. First condition step is work equals work plus allocation and finish of I equals to. If the conditions are true, go to step 2 and repeat the cycle to the end. If the condition finish of I equals false, then we will get deadlock. If finish of I equals true, then we get there is no deadlock in the process. Now we are discussing a question. The question is, consider a system with 5 processes P0 through P4 and 3 resources type A, B and C Resource type A has 7 instances, resource type B has 2 instances, and resource type C has 6 instances. Suppose that at time t0 we have the following resource allocation state is given. In the table consisting of various processes and allocation request available of various instances resources with respect to the various processes. Now we are moving to the calculation part. In the first part, process P0 is requesting instances 000 and it is available due to request is less than or equal to available. Therefore, 000 is less than or equal to 000. Therefore, P0 will get the resources as work equal to work plus allocation. Therefore, work equals 000 plus 010 equals 010. Therefore, work equals 010. In this step, second step, process P1 is requesting instance 2 not 2. It is not working because of request is greater than work. Therefore, P2 will be wait. In the third step, process P2 is requesting instance 000 and it will be work. 000 is less than 010. So P2 will get the resources. Therefore, work equals 010 plus 303 equals 313. Therefore, work equals 313. In the fourth step, process P3 is requesting instances 100 and it will work because of 100 is less than 313. Therefore, P3 will get the resources. Therefore, work equals 313 plus 211 equals 524. Now, we have reached the fifth step. In fifth step, we are processor P4 is requesting instances 002 and it will be work. 002 is less than 524, so P4 will get the resources as work equals 524 plus 002 equals 526. Therefore, work equals 526. Now we are moving to sixth step. Process P1 is requesting instances 202 and it will be work. 202 is less than 526. So P1 will get the resources. Work equals 526 plus 200 equals 726. Therefore, work equals 726. In each steps, every processes are executed. Therefore, no process are in deadlock. Therefore, every process are in safe state. Now we are discussing about detection algorithm usage. If deadlocks occur frequently, then the detection algorithm should be invoked frequently. Resources allocated to deadlocked processes will be idle until the deadlock can be broken. Deadlocks occur only when some process meets a request that cannot be granted immediately. Now we are discussing about recovery. First, possibility to inform the operator that the deadlock has occurred and to the operator deal with the deadlock manually. Another possibility is to the system recover from the deadlock automatically. There are two options for breaking a deadlock. First option is terminate one or more processes involving deadlock, and second option preempt some resources from one or more of the deadlocked processes. About process termination. To eliminate deadlocks by aborting a process, we use one of two methods. In both methods, the system reclaims all resources allocated to the terminated processes about all deadlocked processes. In this method, clearly we will break the deadlock cycle. The deadlocked processes may have computed for a long time, and the result of those partial computations must be discarded, and there is a probability to recalculate them later. About about one process at a time until deadlock is eliminated. Due to the method cause considerable overhead because after aborting each process, we have to run deadlock detection algorithm to check whether any process are in still deadlocked. Now discuss about the resource preemption. To eliminate deadlocks using resource preemption, we successively preempt some resources from processes and give these resources to other processes. First option is selecting a victim. We must determine which resources and which processes are to be preempted and also the order to minimize the cost. The second option is rollback. About rollback, we must be determine what should be done with the process from which resources are preempted. One simple idea is total rollback. That means abort the process and restart it. And last one is starvation. In a system, it may happen the same process is always picked as a victim. As a result, the process will never complete its designated task. That's all about this section. Thank you.